In this video, we're going to continue to develop our solving skills by looking at solving rational equations. Now remember, when we use the word rational in math, that means fractions that contain variables. So when we looked at these before, we added and subtracted, multiplied and divided, and simplified rational expressions. For example, we would add something like this, where we have a couple fractions. They've got variables in the denominators, and the way we went about adding these was we would first need to determine the LCD. So we would have to factor the denominators in order to determine the LCD, then get both the denominators the same, and then we were able to add them together and go into a simplifying step. So that's the idea. Now what we're going to do is work on equations that have these types of things as their objects. Alright, so let's say we have this equation to solve. So basically, when we're solving equations, we can use our properties of equality to manipulate things. So I can do whatever I want as long as I do it to both sides. One of the things I want is for the denominators to go away. So how can I go about doing that? And that's kind of going to be our general strategy, is the denominators are making it complicated, so let's undo that complication. Now, in order to get the denominators to go away, we can't just erase them. That's not a math operation. But what we need to do is first get them to all be the same, so that we're dealing with the same monster, and we're going to try to take out a consistent monster instead of dealing with them all individually. So, in order to get them to be the same, I need to find the LCD. And as we saw when we were adding and subtracting these guys, to find the LCD, we need the denominators in factored form. So I need to go through and factor my denominator. This first one has a GCF of 2. The second one has a GCF of 4, and then the third one doesn't factor down any. So for the left side of the equation, that becomes x divided by 2 times the quantity x plus 1. So on the right side, we have negative 2x over 4 times x plus 1. And then that last term does not, the denominator doesn't factor, so I'll just copy that down. And then I need to determine my LCD off of these factors. The LCD is the smallest thing they all have in common. So in this case, it's going to be 4 times x plus 1, because they all do have an x plus 1 in common. Remember, if all you have is terms, then we're going to create that group of terms as one factor. So they have a x plus 1 in common, and then a 2 and a 4 both have, the 4 has a 2 and a 4 in common in it. So that's our LCD. And then once we determine our LCD, we need to get it so that every denominator has that as its denominator. This factor here is good to go. It already has that as a denominator, so we don't need to do anything with it. The first one here, the 2 is not a 4. So to get it to be a 4 by multiplication is we're going to multiply it by 2. But whatever we do in the bottom, we have to consequently match in the top. And then this last denominator, in order to be the LCD, needs to be multiplied by 4. So again, with this first guy, in order to get a common denominator, what we need to do is multiply the denominator by 2. But whatever I multiply in the bottom, I have to match in the top, because that needs to be able to simplify back out of the problem. That's the only way I can legally insert it. On the right side, that first term is good to go, but on the second term, what we're going to need to get that to be the LCD is multiply the bottom by 4, but whatever I do in the bottom, I do in the top. Now, since the top has multiple terms, to show that multiplication by the entire top, I need to place parentheses around it to group that as all of it being multiplied by 4. Okay, so now that we have our denominators the same, we can kind of start simplifying things. So first of all, I'm going to rewrite the left in a more appeasing manner. That is 2x over 4 times x plus 1. And then here on the right, remember, once our denominators are the same, and these are essentially the same, I can go ahead and combine this into one fraction with that as the denominator and start simplifying the numerator. So I'm going to do that, and the simplifying step I'm going to take in this step is to go ahead and distribute this 4 in that second numerator. That gives me the negative 2x copies down, and when I distribute the 4, it gives me an 8x minus 12. And then that's all over the LCD. So I can do that, but the other big motivation in getting a least common denominator is I really want to get rid of the denominators. And remember, if I do the opposite of what's being done, it'll cancel out. So what this denominator is really saying for us is that this means division. And so that numerator and all of its messiness is being divided by the 4x plus 1. And so if I do the opposite, it would be to multiply by the 4x plus 1. So I'm going to take and multiply by the 4x plus 1 to cause the denominator to cancel out and therefore simplify the problem. And I'm going to write that as 4x plus 1 over 1 just to emphasize that what I'm introducing is in the numerator, and so these two things will end up canceling each other off, leaving me with just the numerator of the original guy. Now, my rule with working with equations is that I can only do that if I do it to both sides of the equation. So I'm going to take that 4x plus 1 and I'm going to multiply the left by that as well. And when I do that, what ends up happening is that it will cancel with the denominator on the left as well. And the reason why that happens is because I took the time to get a common denominator before trying to cancel any of the denominators out. So that means that I can cancel them all in one fell swoop. So now all we're left with is what we have in the numerators. Or in this case, 2x equals negative 2x plus 8x equal to 12. And I can just solve that equation down. This is actually just a basic linear equation once I get rid of those denominators. So what I'm going to do is clear some of this stuff out to give me some room to work what's left here. Alright, so I took out some steps and turned them into ... but I kept the original problem. And now we just need to solve what's left here. So I can combine like terms on the right. That gives me a 6x. Now I have x terms on both sides of the equation. When I have this scenario, I like to get it so I only have x terms on one side of the equation. So I'm going to go ahead and annihilate this 6x by subtracting its opposite, and then I'm going to do that to keep it fair. That gives me negative 4x equals to a negative 12, and then to get the x by itself, I need to divide off that negative 4. Which gives me that x equals to 3. And there we go. There is one thing I need to warn you about with this. Kind of like we saw with our radical equations, the solutions we find don't always work in the original equation. Once we get rid of the denominator, we're really finding solutions to the equation that didn't have a denominator. And not all of those solutions will work in the original equation. In particular, the issue we have to worry about here is division by 0. And so if any of the solutions we come up with cause a denominator to be 0, we have to throw it out because that's not possible. The easiest way to determine if it causes a denominator to be 0 is it would cause the LCD to be 0, because the LCD has all the denominators inside of it. So for example here, if x were equal to a negative 1, that would cause the denominator to be 0. But our value we found is not negative 1, so that means we can say that x equal to 3 is a solution. If we had gotten x equal to negative 1 as our solution, we would have to toss it out. In which case, since that's the only possible one we came up with, that would mean that the result would be that there's no solution. Let's look at another example. Alright, so we have this beast here. Don't let it scare you by its sheer size. What we need to do is focus on the task at hand. We need to determine the LCD. Now, in order to determine the LCD, we need our denominators in factored form. That means we need to factor this guy here. The other two don't factor, so we'll consider them as whole factors in and of themselves. This guy is the x squared minus 25 is a difference of squares. So it'll factor as x plus 5, x minus 5. Alright, so I just rewrote it with that denominator factored. The other thing I did here was I went ahead and changed my minus into plus and negative. That's something I like to do when it's subtraction so that negative doesn't get lost in all of the math. Alright, and I also want to emphasize here that even though this numerator factors, I did not factor it. We are trying to find the LCD. To find the LCD, we don't need to factor our numerators. We actually want to leave them multiplied out. So what that means is my LCD is x plus 5, x minus 5. Now I need to get a common denominator. So this first fraction needs to be multiplied by x minus 5 over x minus 5. The second fraction needs to be multiplied by x plus 5 over x plus 5. And the last fraction's good to go. Thank goodness, it's big enough as it is. So I multiply my first fraction by x minus 5 over x minus 5. Also notice that I surrounded the x plus 5 in parentheses because in order for the whole thing to be multiplied by x minus 5, it has to be grouped together. I multiply the next one by x plus 5 over x plus 5, and then the last one I'll just copy down as is. Now that they're all the same denominators, I can go ahead and do the addition here. In other words, I can write this all as one fraction over the same denominator. When I do that, I'm also in the same step going to go ahead and distribute my 6x and distribute my negative 30. For the first fraction, that's going to give me 6x squared minus 30. And for the second fraction, it's going to give me a plus a negative 30x minus 50. And all of this is going to be over my LCD. X plus 5 times x minus 5. The right already has the common denominator, so I'm just going to copy it down as is. Now that my denominators are the same, I can go ahead and multiply by those denominators, multiply both sides of the equation by those denominators in order to get them to cancel out. Okay, so I have those written in there, and now this is a number divided by itself and it cancels out. On the right, same thing divided by itself cancels out, and we're just left with what we have going on in the numerators. 6x squared minus 30x minus another 30x minus 150. And that equals 6x squared plus 150. So to finish solving this out, we're just going to solve this equation. In this case, it's a quadratic equation. So we want to get it equal to 0 to see if we can solve by factoring. Now, I need to clear out some space to do that. Alright, so I'm just going to start cleaning things up. First of all, we have like terms here. So I can combine that. That's going to make that a negative 60x. And I'm going to subtract my 6x squared from both sides. Because I'm thinking this is a quadratic, so I need to get it equal to 0. But once I get into that process, I'm just like, wait a minute, those are going to cancel out. That's actually a good thing, which will make it go down to being a linear and make it an easier problem than what I originally thought it would be. This happens frequently, but when you see the x squared, you want to think get it equal to 0. Sometimes that ends up canceling itself out during the process. So what we're left with is a negative 60x minus 150 equal to 150. Now to get x by itself, I'm going to add 150 to both sides. 150 plus 150 is 300. So I have negative 60x equal to 300. Then to get x by itself, I need to divide by a negative 60. And that gives me x equal to negative 5. Now remember, with these guys, the solutions you come up with are just candidates for solution. We have to go back to the LCD and ask ourselves what would make the LCD 0. Well, if x were negative 5, that would make this first factor 0, so x cannot be negative 5. If x were a 5, that would make this second factor 0, so we can't allow the answer to be 5. Well, our answer that we came up with, the solution option we came up with, is negative 5. And that's going to cause division by 0 in the original problem, so we have to toss it out and state that it's no solution. Sometimes this is stated as the empty set because there's nothing in the set of solutions. Okay, go ahead and give some of these a try on your own and see how you fare.